Welcome everybody to my first project that I'm putting on the internet. I do a lot of projects, and I people have suggested that I should make little YouTube videos because other people might find them interesting, and so I decided to go ahead and try to do that today. So this is my first project that I'm properly documenting for YouTube. Um, I've got some slides that I'll show during the process as I'm kind of talking in the background so you can see what I'm talking about. But what I'm showing you is the code. So basically the problem is I have a snake and he is inside of a enclosure, and I like to conserve a lot of power and energy as much as I can. And so my house tends to swing in temperature a lot throughout the day. In the morning, it can be quite cold, and then by the evening, 4 or 5, it can be quite warm, especially where I live. Right now, the weather is very volatile, so we may have days in the mid 70s, and we may have days that never get above 30 still. So that means that the demand on the heating lamps for my snake to keep them in the range of 80 to 88 for the snake that I have is quite difficult if you're not there to tend the tank all the time, which I'm not. We're very busy, and so I needed to have some sort of automated system that could monitor the snake's temperature and turn on or off heat lamps accordingly to maintain that range of 80 to 88. So, so we have here the very top of the code. You can see that we include the library for the DHT11 temperature sensor that I'm using. We define it to pin 5, and we define what the DHT type that we have. This actually was a bit of an issue for me when I was running the code because I had downloaded some sample code to just get me started to build on, and it was for a DHT22, and I couldn't figure out why I kept having the sensor not found pop up on my serial monitor, but figured that out, so that was nice. Then right here we just define where the infrared relays are and what pin they're on. Now, a little bit more about my setup. I have one lamp that is a visible heat lamp, and then the other two are just infrared. And so I wanted to, in the program, be able to differentiate which ones were turning on and off. This is the first pass of the code, and I do want to make it more capable. And you'll see some code in here like this that we're not currently using, and I'll explain that as we get there. So, ignoring this part of the code, it's going to be updated anyway. We have our setup where I wanted to make sure that the relays were working and switching when I first boot up the Arduino. So we turn on the setup that I have, the relays high is on and low is off. So we turn the relays on, all of them, for about 10 seconds, and then we turn them all off for about 10 seconds. That just lets me make sure that they're switching correctly and we don't have a problem. There's no wiring issue. Then we start the loop. Um, and this is where we're going to read the temperature. And if we're not getting temperature back, so this is NaN, basically says if it's returning something that's not a numerical value, then it's going to say fail to read from the sensor. Then right here, I only have one sensor in there. I want to add some redundancy and backups to the system as well, but I don't have that in place right now. So I figured if the snake decides that he finds the sensor in the enclosure and pulls it off of the cables, or the sensor goes bad, or anything happens and we don't get temperature data back, I wanted something to happen. And so basically I write low to the visible relay and the secondary infrared relay, and I just turn on one of the heaters because in testing with one of the heaters on, it can get up to about 90, 92 degrees in the enclosure in the middle of the day, but at least he won't freeze overnight. If I lose that sensor at night and it's 30 degrees outside and my furnace doesn't kick on, um, ultimate fault state, we fault to just one relay on. Not ideal, could potentially be dangerous for the snake, but the best failure that I have right now would be to have one light on, and then catch it, of course, when I get back home. And then this is for testing. You can see down here, and I'll show you in some of the videos. We get this stream of temperatures coming through on the serial monitor. That just helps me diagnose problems in the code. So then here comes the if statements, all of the conditional statements. If our temperature is below 75, so something has happened. We try to catch the temperature before it gets to 75, but if I have a bulb that burns out, or the temperature is dropping really quickly, or some other failure happens, and the temperature is below 75, that's like a critical point. I don't want it to be below 75 for my snake, so I just turn everything on. And I added a little delay because in testing, when I was trying to switch all three relays on at the same time, sometimes one would not switch. And so I just put a little delay, so it's one, then the other, then the other. It's 100 milliseconds, and so it's almost imperceivable, but that's why that's there. So this is temperature below 75, critical state for the snake, all the lights turn on. That should never happen, but if we get there, this is kind of a failure catch as well. If the temperature in Fahrenheit is below 80, then we need to turn on an additional heat lamp. So the maintenance heat lamp condition is to have one heat lamp on all the time. So if we get below 80, then we need to turn on an additional heater. So we put the second infrared relay to high, which turns on the second one as well for heating. And then I have this little bit of code here because in testing what was happening is I was just fluctuating. I'd go to 80, 80.5, that second heat lamp would turn off, and then I would drip back down to 79, and the second heat lamp would turn back on. So I had a lot of relay switching, which is going to wear the relay out faster, obviously. And every time we have a relay switch, it's a potential point of failure. So we want to decrease the number of relay switches that the program has to do, that the Arduino has to do. And so while this is true, then we're going to read the current temperature, and then we have that failure, potential failure again, where we just stay with one on. But if it was below 80, and then now we're heating up and we've got the second lamp on, we get this on the serial monitor where it's like, hey, we're heating up. And then when the temperature is equal to or greater than 87, then we get this printed out and it shuts off it breaks that loop. And then I can show you what happens next, put a little delay in there again for relay switching. And then after we get to the target temperature, we're going to turn off everything if the sensor reading starts failing at that point. If we've like melted through a wire or something, we don't want to keep heating if we can't check it, because with two lamps on, we'll get way too hot and the snake will cook. And so this just catches, hey, we're going up to temperature, and it should be covered by the other condition as well. But I wanted this one in here just as a double check. So as we're heating up, if we lose the sensor in this loop, we will cut off everything. Then if the temperature is above 88, we turn everything off, because obviously we're too hot. We don't want to keep going up. So if we get above 88, everything shuts off. Then this is like where we want to ride. This is where we want to maintain equilibrium. If the temperature is greater than or equal to 80 and the temperature is less than or equal to 88, then we're just going to have one lamp on. The hope is that we just keep one lamp on. We get up to 82 and we turn one lamp on, and the heat leaving the enclosure is the same as the heat being provided to the enclosure, and we can just ride in this 80 to 88 zone all day. That would be ideal. And then at night we kick the 2 on, goes to 87. We do a little bit more intermittent heating at night to maintain that temperature. And then we have a delay. I originally had the delay be 5 minutes. I wanted to sample every 5 minutes, but there's a lot could happen in 5 minutes. If I've got two lights on, if I turn two lights on, in 5 minutes we could be up to 95 degrees. And so I ended up taking this delay down to 500 milliseconds, which is very quick. Not the fastest we can do, but very fast. We get constant readings, and so it's essentially constantly checking the temperature. And then we run that loop again. So we're just constantly checking. And here's some video of the tests. So this is a video where we are checking to make sure that it will shut off, because we don't want to cook the snake. So as you see, the temperature is rising really rapidly. I've got the sensor in a place where it's being heated right now, and we hit that and we get an instant shut off of everything, exactly as designed. And then here we have a test of turning the second light on when we're getting just a little bit low. So you can see the temperature is slowly coming down, slowly coming down. We hit the threshold, and now that second light turns on. And then we're going to heat up to 87. We don't want to just fluctuate around 80. We want to be between 80 and 88. So when we get up to 87, right here, you can see that second lamp will shut off. And now it will start to cool back down or hopefully stay there, but if we get above 88, then we'll shut everything off. And what I didn't want to happen was I was worried about a constant swing where we're heating up from 79, and as we pass through 88, then everything shuts off. So I want to leave a 1 degree buffer between, okay, we're heating up, we're heating up, we're heating up, let's shut off one light, and then we have a little buffer, we can go above 87, but if we go to 88, then everything shuts off, or above 88, then everything shuts off. And so that gives us a little bit of a buffer where the temperature can fluctuate. So far, this has been working great. If you want a copy of this code, just ask in the comments. I mean, you can see it here, but I can give you a copyable version. Some things I want to add. I want to add redundancy. I want to add another temperature sensor so that if we lose one, we can use the other one, or we can monitor different portions of the tank. The snake that I have is a king snake. He's a desert snake, and so we don't really need to worry about humidity, but it can get very dry. I live in the high desert, and so I would like to add a mister and check the humidity. The sensor, the DHT11, can also check humidity. And so I want to add a humidity loop where we have a mister in there and we can maintain a humidity somewhere maybe in the 15 to 20s, and we can turn that up when he's shedding. And I would also like to add redundancy in the relays. The relays that I got are just cheap relays from Amazon, and they work well, but they do sometimes get stuck. That's why I had to add the delay in there as we're sequentially turning on more and more relays. It could be a power distribution issue. There's a lot of things it could be. If you have any comments on that, post them below. I'll kind of describe one of the failures I had with one of my sensors. I'm sorry, one of my relays. And if anybody knows what would cause that, if you could let me know in the comments, that would be great. But essentially, we went to turn on all three at the same time for that max heating, and one of the relays just continued switching on, off, on, off, on, off. And it's obviously not a code issue. And the relay works when I'm powering it up. When I did the power up and we turn them all on immediately, it was functioning. But then when we got down here in this loop, this relay, infrared relay 2, just kept on, off, on, off. It was interesting and concerning because if I'm not home, I don't want a relay switching continuously until I get there. Potentially have some mechanical failure or electrical failure of the relay. So there is more to come. Oh, another thing I would like to add is I want to add where the daylight, in the visible light heating lamp, has priority right here, has priority over the infrared lights during daylight hours. If I can have this one on instead of one of these during daylight hours, that would be great. So I do have a integrated clock coming in so that I can add a clock to my Arduino build. So if the program knows, okay, we're approaching, say, 6 a.m., we're going to shut off the infrared only heating lamp and we'll turn on the visible light heating lamp. And then we're going to primarily use the visible light heating lamp throughout the day to maintain that temperature, that 80 to 88 right here. And then once we reach, say, 7, 8, 9 o'clock at night, then I want to shut off that visible light and give priority back to the other infrared relay infrared one, which is my primary heating lamp. So that's another loop and more programming that I want to add. So like, follow, subscribe, click the bell so that you get notifications as this project continues on. If you're interested in other projects, I have done numerous other projects around the house, and we do some robotics, and we're planning on making more of these videos. So let me know what you think about this format, and we'll see you in the next one.